with the recording, and I have a quick question for you, Federico, because I had the people at home, and I was on the only for some time, so I lost something. The preparation of flattening the page or remove the spots.
Yeah.
You can do it when you make the acquisition of the page, so in the phase of the scanner, or afterwards with I don't know, I don't know, a type of a Photoshop software, or when you can, of course, thinking to a manual operation, not an automatized one.
Yeah. So for sure, it is better if I recap. Okay, I said that for sure it is better if you can flatten physically the page as possible. Okay.
I was thinking, okay, I am with my iPad in an archive, and I take the picture of the manuscript. So.
Yeah, of course. If you cannot do that naturally, you can use some software, okay, before the optical character recognition, just to prepare the page. And now, for a general recap, okay, I will ask somebody of the students, for example, Lorenzo, if he's available, okay, to follow step by step, naturally not for a long time, okay, but to follow and comment, okay, step by step this operation. So Enrica, you will see them live, okay?
Okay, thank you.
Okay, so Lorenzo, are you there?
Hi.
Hi. So perfect. Now I open Scantailor. Okay. As I said, it isn't necessary that it is Scantailor advanced. You can use other software. Now we see just the type of operations that must be performed on the page. Okay.
Hi,
so,
sorry, can I interrupt just for a second?
Yeah.
I'm Margherita.
Yeah.
Could you repeat, please, some of the programs that we can use except from the one you said? Because I couldn't write them down, and I'd like to download one of these programs.
I use Scantailor Advanced. Do you want that I write it in chat?
No, I got that, but I wanted other programs because I was not able to download that one. So I wanted to try with another one.
Okay, so yeah, for example, if you use Abby Fine Reader, for example, okay, it is these operations are integrated, okay, and some of these operations, not all of them, are possible also on Photoshop, for example, or GIMP, okay, so GIMP, okay, so the rotation, binarization, and so on. It is just the warping that it is very specific for OCR, okay, and in any case, if you use Windows, probably you use Windows, exactly?
Yeah, that's why I couldn't download the other one.
I suggest you to install, okay, on Windows an emulator of Linux, okay, and so you can install Linux on Windows, okay, and then to use the Linux software, okay. There are also the virtual boxes and so on. If somebody of you are interested in this operation, okay, they can write to me and I can give you more specific information, okay, how to install a virtual box, for example, in order to use Linux on a Windows system, okay.
Okay, yeah, that the Linux one was my plan B. So, okay, thank you very much.
Okay. Okay. So I start from the beginning. Lorenzo, are there?
Yes, I'm here.
Yeah. Okay. So I launch Scantailor. You see that we can use a previous project, okay, or you can create a new project. In this case, I create a new project. I must declare.
I don't see your screen. I don't know if you shared the one.
Oh, sorry. Sorry. Okay. I start again. Okay, thank you. I start again. So, Scantailor, the new project, the input directory. The summer school is here. Okay. I open it. Okay, so first of all, I fix the DPIs. It is better to fix them always, even if they look okay. Okay, so I say okay. So all pages, and I want that they are considered as if they were 600 per 600 DPIs, okay? As I said, it is just matter of the metadata, okay? So, okay. Okay, so Lorenzo, what do we have in front of us?
Should I say what I see in your screen? Sorry, I didn't.
Yeah, exactly.
Okay.
Yeah.
We see a page from the Rerum Natura.
Yeah, exactly.
So I think we should now do some operation neat.
Exactly.
Like
which operations are necessary?
Well,
you're surprised. I guess that you are not surprised, okay, that in this kind of images, okay, we haven't just the text, but we have the entire context in which the image has been acquired. No, you see that there's a black background, okay, on which the book has been putted. Very probably it has been acquired by a camera, okay, and so which are in your not just in your opinion, but according to what we have seen, the operations that are necessary?
Well, I think we should cut off what we don't need. I mean, ritagliare. Sorry.
Yeah, exactly.
I don't know the word in English. Then
select just to select the
the
box.
portion of the page, eliminating the black background.
Exactly.
Then I think we should move the page in a vertical order.
Yeah.
Maybe. Then.
So these operations must follow a sequence, okay?
Mm-hmm.
Because if they are performed automatically, okay, the system must recognize the next steps, okay, according to the previous ones, okay? So for example, in order to recognize a text box, okay, the orientation must be fixed, okay? So you see on the left side, okay, you see that we have 6 steps in this order: fix orientation, split pages, deskew, select the content, add margins, and make the output. Okay, so we start by fixing the orientation. And this is an operation that unfortunately it doesn't perform well automatically. So it is better that we make manually page per page. Okay, so you see, rotate. So I rotate it.
Mm-hmm.
Okay, so I rotate all my 6 pages of the sample. Okay. And also this one, a bonus. Okay. And so I have fixed the orientation. Now we try to split them. You see that here we have the page layout. This is a very nice operations that is well performed automatically. Okay, you see that we have the page layout. The first one is the single page. Okay, the second one is a single page with something on the left or on the right of the other page. Okay, because the page, the image has been cropped. Okay, and the other one is when we have 2 pages. Okay, and the system is able to understand that you have 2 pages and to find the point in which it must separate them. Okay, so in this case, this is a good recognition. I perform it automatically on all the pages. You see that the system has cut all the page quite correctly. In this case, I can adjust it. You see?
Yes.
You see that I can adjust this, no? For example, here. Okay. Okay. Then I must deskew it. Also, in this case, I apply it to all the pages automatically. Okay. And you see that I can work on it also manually. Okay, tell me when I must stop. Here, I guess, no? Do you see that now the text is aligned? Okay.
Yes.
Okay. And then I must select the content. Even in this case, it can be performed automatically and then adjusted manually. Apply to all pages. Okay, so I want to apply to all pages. I want to select the content of all pages. Okay, and you see that also in this case, it is quite good. You see? Automatically, it has recognized the text boxes. Okay. For example, ABI Fine Reader is very good in this kind of operation, okay? That is the layout analysis, no? To identify the boxes of text inside the page, okay? And then I add margins. Okay? And finally, the output. So now we can answer to Enrica's question. You see that we can perform the despeckling, and I can ask for a very aggressive despeckling, okay? In some cases, okay, this 3, I won't see if it, you see that it is a row, it is cancelling, it is deleting a little bit too much, no?
Yeah, it's clearer.
Okay, so it is better. I'm not able to go back. Anyway, I've understood. I don't want the speckling at all in this case, okay? But you see that here are a speckle, for example, a spot, no, close to 505, no, to the 505 verse. There's a speckle, okay? If I perform the speckling, it should be cancelled. Yeah, you see? You see the difference? After Labens, okay, after Labens, there's a small speckle, okay, and if I perform the despeckling, it is cancelled, okay, and naturally this speckle is smaller than the punctuation mark, okay, otherwise they will be cancelled, okay, but I don't perform the despeckling. And then, as you can see, I could decide also to have the margins that are not filled. So you see, in this case, I have this artifact on the margin, okay? But I prefer naturally to eliminate the margin. I could equalize or not the illumination. I could try to smooth the image. Okay. You see that some operations are too much aggressive. So, for example, I prefer not to have the morphological smoothing because it can sell some smaller lines. Okay. And then also the mode. I want the black white, but I could choose also to have the original color with a margin that is on the same color of the background, okay? And if I equalize the illumination, you see that the colored image is more homogeneous, no? Okay, but naturally I prefer to have black and white images. Okay. The warping, and now the warping, the manual warping. Okay. Okay. If I go here on the warping, you see that I can act on this grid, okay? So this is a very good image that don't need it. So now I make the contour just to demonstrate it how it works, okay? you see that I can move this grid, okay? And so now I make it worse naturally because it was very good at the beginning, okay? But if I perform it to this page, okay, you will see that it will be deformed. Where is it? I go back. Yeah, you see that I have deformed it. Okay, naturally I have the contrary situation, no, in which I have an image in this situation, and I try to normalize it. Okay, is it clear, Enrica?
Oh, no, it's very clear, and I think that if you do what you are doing now, the system send you a message. Are you stupid? I was flat. No, it's really clear. Thank you.
Okay, so naturally this was a good image because we used a flatbed scanner, but I assure you that sometimes I ask to the students, for example, to send me some images, okay, and some images of books, okay, and they are very proud. Okay, I go in the library, I make a picture with the smartphone, okay, and naturally they are a lot of deformations, okay, so they have artifacts that I must yeah, exactly, that I must correct in this way, okay. In particular, the pictures that we take with the smartphone are totally to be adjusted, okay, so they must be adjusted because otherwise the OCR is very, very poor, okay. Some other questions now that we have the instrument in front of us? So probably you want to see where the output is saved, probably. Okay. So if I close it, yeah, I save the project. So the project save all the metadata related to all the operations that have been performed on the original images in order to create the final images. It is similar to a script, okay, that contains all these. So I call it the Natura 2, okay. We can also open it, okay. LS, so the summer school, okay. If you want to see how these metadata are saved, you see, and it isn't a surprise. I just add, so move and to, okay, XML in order to see the syntax highlighted. Okay, you see that not surprisingly it is an XML file, okay, that contains all these metadata. You see it is declared which are the files on which we are working, which are the original size, which is the DPI of the image, okay, and the operations that are performed on it. So you see precisely it is written where it is split and so on. So you have all the necessary information to understand which operations have been performed on our images. Okay, the images are naturally inside the destination directory. Okay, so if we read it, for example, 0054, okay, you see that now we have in front of us an image that is ready to be recognized by OCR. Okay, without the black background, without the color, despeckled if I had applied it, and so on. Okay, perfect. So it is late. It's better that we start with the second part, okay? Because we worked a little bit on the images, and now it's time to afford the topic, the main topic of optical character recognition. So there are many commercial applications, but really many commercial applications to perform OCR. For example, ABBY FineReader. ABBY FineReader 15 is a very good commercial product for OCR. Also Adobe Acrobat Pro, okay, and among many other comparative evaluations, you can see this page, okay, in which you, yeah, it is really a commercial website, okay, but here you see a comparison, okay, between 10 different products, and the key features are illustrated, okay? So some of them are very expensive, some others are very cheap, and so on, okay? And there are also many solutions online. For example, I don't know if you know it, there's a new service on Google Drive to extract text from PDF of images. So you upload a PDF file and you have the text mapped on the images. I mean, naturally, a PDF file without text, without the text, okay? So a PDF file that is just a collection of images, okay? And the OCR is automatically performed on it, and the text is mapped on it. And finally, there are many apps to capture images with a smartphone and convert them into text or searchable PDFs, as I said. Commercial applications, so which are the strength points of the commercial applications? The main advantages are that they are simple to install on Windows and Macintosh. They are easy to use. They have a graphical interface. Okay, so for occasional users, they are in many cases a very good solution, okay? So don't use very difficult software if you don't need it. For example, if you have a manual of history that has been published last year, okay, it is probably better that you use just ABI Fine Reader and that you make the acquisition of the parts of the text that you need with this software. Okay, as I said, the operations that we have seen in the previous part of our discussion, okay, are performed automatically by many commercial software. So, for example, ABI Fine Reader make the binarization, the fix the orientation, and so on, everything automatically. Okay, but there are also the weakness points. Otherwise, I wouldn't illustrate you some complicated software that must be installed in a difficult way and that has no graphical interface and so on. The main issues of the commercial software are the necessity to renew the license for the new versions. For example, this happens even a few days ago in our center, okay, in which we had the license of ABI Fine Reader 14, okay. We wanted that works, okay, but we needed to acquire the text of the text of a book with the fractal fonts, okay, so the Gothic fonts, okay, for old German books, and this package for this kind of recognition is available only for ABI Fine Reader 15, for example, okay? So we hadn't the license and we needed to change the strategy for the acquisition, okay? Then the scalability, where you must pay per page recognized, the cost can be no more sustainable. What does it mean? It means that for large for massive initiatives, the costs can be huge if you use commercial software. This happened, for example, at the Perseus project when I worked there, and we started working with ABI Fine Reader. Okay, so ABI Fine Reader wasn't a viable solution for massive optical character recognition because they asked us fees per page, okay? And so we started working with a totally open access software for the optical character recognition. And as I said, languages. Fine Reader has additional packages for old or ancient scripts, such as Fracture, okay, but not for all the scripts, and for some of them is not optimal, okay. So it is important to evaluate what you really need, okay. So I say if you have a simple project, the commercial software can be the best solution, okay? But if you have a challenging project, if you have a research project that is based on the acquisition of challenging documents, you should evaluate the opportunity of using other solution, of adopting other solutions. So the open source applications for OCR. The most performant open source applications for OCR currently, so nowadays, are Tesseract and Octopus. Octopus that has many derivatives, and the most interesting are Kraken and Calamari. Naturally, there's it's a joke, no? It's a joke because OCR opus, okay, it is similar to octopus. So Kraken in German means polyp, okay, so, and calamari, okay. So Kraken, yeah, means octopus in German, and then there are calamari. And another interesting OCR project is Gamera, but now it isn't so updated. Okay, we used Tesseract and Gamera at the Perseus project to acquire ancient Greek. Okay, for that project we used Abby Fine Reader that at the beginning had no training files for ancient Greek, so we applied the model for modern Greek that probably, as you know, is monotonic to the ancient Greek. So the first result was totally without breathing marks and grave and circumflex accents. Okay, and we corrected manually a small amount of pages. 10 pages were enough, and so we created a new model also for Abby Fine Reader in order to have in 2008 the ancient Greek polytonic model to recognize texts in ancient Greek polytonic texts. Then in the next years, we, as I said, used only open source software, and so we used Tesseract, and Bruce Robertson used Gamera. And then I will show you some projects in which this software has been applied. Okay, so which are the strength points? Main advantages of these projects are the scalability to process millions of pages, the scientific research to process challenging documents, okay, the endangered languages, ancient languages and scripts, low quality paper and ink, damaged documents are research topics, okay, and there's a really big scientific literature about OCR, and that you can find, for example, on the ACM digital library, okay, and you can find papers that are related to the improvement of OCR accuracy. And these kind of projects have the support of the community. So if you have specific questions, you can ask to other experts, and you can share knowledge, and you can share training data in order to improve the OCR accuracy on new documents. But there are naturally also many weakness points. Many issues of these projects are incompatible versions in the quick evolution. So, the drawback is also the fact that you have incongruent, that you have inconsistent documentation, okay? Because something works very well on the previous version that currently maybe is obsolete, okay? And the documentation is related to the previous version, but not to the new version that could be incompatible, okay? And in particular, all the satellite tools, okay, that have been created for a version could be not updated for the new versions. This is a big problem, okay? For example, to train an OCR engine, okay, usually you are facilitated by graphical interfaces, but these graphical interfaces in many cases are related to a specific version of the software, okay? So you are really, when you use this kind of software, you are really involved in the research. You are part of the research on the OCR. You aren't just an ingenious user, okay? In many cases, there are no graphical interface, but only the command line is available. And this is justified by the fact that, as I said previously, these projects are very, very performant on huge amounts of documents that must be processed. And as Margherita said, they unfortunately are not available for all the operative systems in many cases, okay? As I said, the workaround is to install a virtual box, okay, on your operative system in order to emulate another operative system, for example, Linux. Many of these projects run under Linux, but if they run under Linux, in 95% of the cases, they can run also on the Mac. So, what is an OCR engine? In simple words, an OCR engine is a classifier which assigns a label, it has a character or a sequence of characters to an image region. For this region, the most recent OCR engines are based on neural networks because neural networks are very good in classification tasks, okay? What does mean? It means that we identify a region of the image, okay, at different levels of granularity. We are interested at the level of the character, okay. So the small region for a single character, okay, and to this small region of the single character is assigned a label, okay. So I would discuss with you, for example, Lorenzo, are you still available?
Yes, I'm here.
Okay, so just to make a question, which are, in your opinion, the main issues that we must address in order to assign a label? That means to identify the characters, okay? So, for example, to say this is a C, this is a T, okay, to a region.
Well, the first thing I think about is that the same letter could be written in very different ways. I mean, paleographically speaking.
So yeah, so in this case, you are speaking about HTR systems. I mean, you are speaking about handwritten text recognition. Okay, you are correct. Okay, in this case, absolutely. Okay, because at C, if it is written by hand, okay, C, a T, and so on, can be written in different ways, and in some cases in very different ways. Okay, but this issue, that is the main issue in handwritten text recognition, is reduced for optical character recognition. Okay, so we are trying to recognize characters that are typographical characters. Okay, they are in printed editions. Okay, so in printed editions, which other issues can we have? I ask that because if we are aware of the kind of issues, okay, we can be more focused also on the possible solutions when we must correct the test manually. Okay, so try to imagine issues related to the recognition of printed characters.
Okay. Well, the quality of our printed work could be very different too.
Yeah, exactly. So these can create artifacts as we have seen. For example, a speckle, okay? When we have a speckle, okay? Imagine to have speckles over the three vertical signs of an M, okay? In this case, this M could be recognized as a sequence of the eyes, okay? Another very big problem is when the elements of the characters are separated, okay? So for example, if the small parts of the small arcs of an M, okay, are not visible. Okay, also in this case, instead of an M, the system could recognize the I, or even worse, an N followed by an I. Okay.
Mm-hmm.
And another problem are the ligatures, okay? Because when you have ligatures, a single region contains more than one character, okay? So these ligatures must be recognized as a unit, okay? And they must be separated in a second step, okay? But the label that is assigned to a ligature, okay, is the couple of characters, okay? Imagine, for example, F and I in Einaudi edition, no? In which the dot of the I is connected to the F, no? Okay.
Mm-hmm.
Perfect. So these regions must be recognized, and the characters must be assigned to them, must be related to them. So naturally, we must have we must have images that have a high quality. If we see, for example, that changing brightness and contrast of the image creates some artifacts as the separations of the elements of the characters, we must work on the image. Okay, perfect. And in order to assign a label at the character level to an image region, regions must be identified by layout analysis and segmentation. The layout analysis decomposes the page in its textual and graphical components. Okay, so for example, columns of text, illustrations, and tables. Okay, and AB Fine Reader, for example, commercial software are quite good in this layout analysis. Okay, in some cases you could combine the layout analysis performed by commercial software by using the data, okay, of the layout analysis with the an OCR engine like Tesseract or Octopus. Okay, so when you have identified the blocks of text, you must segment them. Okay, textual blocks are hierarchically segmented in lines, words, and characters. Why hierarchical? Because lines contain words and words contain characters. Okay, you can see that in a line of text we have the height of the X, okay, that is considered the body of the character, and then you have ascenders and descenders. Okay, in some cases, in particular in old editions, the descenders are unfortunately joined to the ascenders of the next line, and this creates literally a mess if you haven't a good segmentation, because the character the character of the upper line is joined to the character of the bottom line, okay, and of the lower line, and they are misrecognized. Okay, and then when you identify the single characters, okay, when the system identified the single characters, it must be aware not only of the single space of the boundaries of the character. Okay, so for example, the box that contains the of the first the first E of être must contain also the accent. Okay, but it must calculate also the spaces. Okay, you see, for example, in this case, how spaces varies. Okay, so words could be separated. Okay, in so one word could be wrongly split into words. Okay, so bad segmentation causes bad OCR. Factors that must be taken into account are that you must avoid artifacts during the image acquisition process, such as page warping. When it is possible, pages should be unbounded, as I said. Preprocess the images to reduce the artifacts, and if an OCR engine makes bad segmentation, try another one. For example, if IBFan Reader doesn't satisfy your needs, try Tesseract or Kraken, and vice versa. Okay? And now we must speak about the training data sets. Both commercial and open source OCR applications are provided with pre-trained data sets. For this reason, we can perform the optical character recognition on a variety of languages and scripts without taking care of the training phase. Okay, so if Tesseract works immediately on English text, okay, on a recent English text with a neutral, in certain sense, font, in a very common font, okay, it is because it contains, it is because it uses trained data sets that have been created by the creator of software or by independent groups that put at your disposition their work. Okay, so for example, for ancient Greek or also for Arabic, or also for Hebrew, or also for I don't know, for Old German, as I said, there are training data sets both for commercial and open source software. Okay, so first of all, we must identify which are the language, which is the script of our text, okay, and then we must choose the best training set available, if it is available and if it is satisfactory. But when the accuracy of the recognition isn't satisfactory, it's necessary to train the system. Training is based on an accurate association between text and image. What does it mean? It means that we must create couples, okay, of text lines and their accurate transcription, manual transcription, okay, and each engine has its policy. So I mean that, for example, Tesseract works well even at the level of single character, okay, so you can provide Tesseract just with the list of the single characters for your language. So, for example, for Italian, all the letters with the Italian accents. For German, all the letters with the umlaut. For ancient Greek, all the letters with all the combinations of braiding marks and accents. Okay. Other engines, on the contrary, need to have characters in context, so you need to provide text lines, okay, text lines with their transcription, and automatically adjust the boundaries of the single characters or ligatures, okay? The text that exactly matches the image is called ground truth. So this term is extremely important in the studies about OCR, in particular, to evaluate the performances of an OCR engine. Some OCR engines, just Tesseract, need a small amount of ground truth. Some others, on the contrary, need a large amount of ground truth. Okay, why Tesseract can work also with a small amount of ground truth? Because, as I said, it can give good performances, even if you just make the training set with the list, with the sequence of the alphabetic characters that you will use in this text. So few lines, okay, are enough to have quite good results. Other systems, on the contrary, need a large amount of ground truth. Naturally, handwritten, as Lorenzo pointed out, handwritten text recognition, okay, has a big variance, okay, of glyphs, and so you need to provide a large amount of ground truth. For example, if you make a new training set for Transcribus, okay, you could need 1500, no, 15,000 words. So large amount of words, okay, so 15 or 20 pages manually transcribed, okay, of the text, in order to have a good recognition of the rest of the text. So, for example, you have a document, okay, with 400 pages. You transcribe accurately, very accurately, manually, the first 20 pages, okay, and this transcription is used to recognize the rest of the document. Some questions? No? Okay. You see, for example, as I said, Tesseract in this case, okay, so here we are providing Tesseract with the transcription of these letters that are on the left, okay, so you see the character A, okay, and the coordinates, so something that allows us to identify the text box that contain it, the character box that contain it, okay, and the image of the character, okay. So always a pair, okay, also always two things: the ground truth, that is the transcription, okay, and the image with the coordinates, okay. Yeah, if you want, you can consider 3 separated things. So the character, the image, and the boundaries of the character inside the image, okay. But the other OCR engines can be trained even without providing the code, without providing manually the coordinates, okay? Because also the segmentation is trained by this kind of OCR engines, okay? So for example, Kraken needs lines of text, okay, and the transcription of the entire line, okay, and it learns automatically how to segment, how to divide the characters, okay, how to identify the regions that contain the characters, okay. So when we want to perform the OCR, okay, by Tesseract in this case, so this is just an example of an OCR engine that uses the command line, okay. You call Tesseract, you provide the language. It isn't just the language, it is the minus L, okay, means that I provide as a parameter, okay, the training data related to Italian and Latin. By plus, it is able to combine different languages in the case you have multiple language documents, okay. If you have just one script, it is better that you use just the training data for that script, okay. Why? Because it could recognize the characters of one script wrongly by assigning them to another script. For example, if you use Latin and Greek, okay, an alpha could be confused with an A beta, okay, a capital beta could be confused with a B and so on, okay. So it is better that you limit the combination of languages only when you have effectively a multi-language document. Then you provide the name of the image, okay, and the name of the document that you must generate without the suffix, okay. So without the extension, because the extension is assigned according to the format that you want. If you don't write anything, you will generate, if you don't provide anything, you will generate just plain text, okay? So a doc001 document, a doc001.txt document will be generated. But on the contrary, you could prefer to generate an HTML document that has some information related to the mapping of the text on the image. Okay, and we will see this in a few minutes. Okay, this is I prefer to show you. So just a small interruption. I prefer to show you how it works. Okay. Okay, so ls. Here I am in the directory that we have seen previously. Okay, and so for example, zz. Okay, you see this is our page that you want to recognize. I make Tesseract. So when I launch Tesseract, I can ask help. Okay, you see Tesseract help. You can see which languages are installed. Okay, Tesseract list langs. Okay, you see that in this moment I have installed only the Fraktur, the English, Greek, Ancient Greek, Italian, and Latin. Okay, and another one that OSD, probably is Occitan, probably. Anyway, I have installed only few of the available ones. Okay, how do you install them? You must put the training data files inside a specific directory. Okay, help extra. Okay, in a specific directory that you can also change. You see, test data directory, and you can decide which is the directory in which the training sets are available. Okay. So I want to make something simple. I just indicate the training set I want to use. I want to use Latin because the text is in Latin. I give the name of the image, that is 0045. I give the 045 without anything. Okay, and I perform it. Okay. Okay. ls zeta 0045. No, doc 00. Okay. Okay. And this is the recognition. Okay. That is quite good. It isn't perfect, but it is quite good. Okay. And as you can see, considering that I decided that I didn't want to despeckle the text, you see that these speckles are creating some problems, you see. So if we compare the image with the recognition, okay, so which is it is 45. Okay. Okay. You see that after rigorem, you see, brumales usque ad flexus celi dunque rigorem, okay, there's a spot, and this spot has been wrongly recognized as an apostrophe. Okay, if I performed the speckling, I had better results. Okay, why the numbers are here? Just because I should adjust the segmentation modes. For example, if I indicated as segmentation mode, assume a single column of text of variable sizes, okay, instead of having the numbers here, okay, as if they were in a different column, okay, they had been recognized in the correct way, okay? Okay, so next step, yeah. This wonderful format, okay, is a microformat, okay? This microformat is what is a microformat? Microformat is an embedded format inside another format. So inside an HTML file, I can encode, okay, I can embed the information related to the coordinates of the regions that have been recognized. You see that here we have an HTML file, okay, and we have the division in page, in areas, in paragraphs also.
Actually, Federico, is that really small, the images, so we cannot see anything.
Yeah, I enlarge it. Do you see it better?
Better.
Better. Okay, perfect. So you see that here we have an HTML file. Okay, so it is a simple HTML file. Okay, but the information related to the bound boxes. Okay, so the regions related in this case of the words, okay, are encoded inside of the title, okay, of the span, okay. So the span has the class OCRX word, okay, NID, okay, and the title, okay, contains the boundary boxes, okay. This is an old format now, which HTML5, this information could be encoded in a better way with the data attributes, okay. But in this microformat, they are encoded inside the title, okay, inside the class and inside the title, okay. So here you see that you have the information necessary to link, to map the word on the image, okay. And you have also a degree of confidence, okay, that can be exploited. Sorry, why? That can be exploited, for example, to color in a different way the words in a correcting system, in a system to correct the text. How the confidence is evaluated? The confidence is evaluated according to the probability of the single characters to be correct, and the probability that the word is effectively a word of this language, okay. So the training data, so the package that contains training data usually contains also a dictionary of the language in order to compare the recognized tokens and evaluate if they are effectively words of that language. Why? Because, for example, if you identify, I don't know, mamma or mamma, okay, the probability that the correct spelling is mamma with two M's in Italian naturally is bigger than it is mamma that doesn't exist in Italian. Okay, so combined it also to the probability of the single characters. For example, the probability that it is an M is bigger probably than it is an N. Okay, make the system to associate a bigger probability to mamma instead of mamna, and to select this one in the output. Okay, I will show you. Yeah, it is better if I show you it immediately. Okay, so you see that if here I write OCR, okay, OCR, I will generate I will generate a I add move the HTML and okay, you see now it is it doesn't the BRs because I should work on the CSS, and now naturally we haven't time to work on the CSS, but I manually add a BR instead of working on the CSS. So I just put after each line, okay, after each line I add, okay, so replace string this one with R, okay, should be enough. Okay, no, just a moment. Okay, replace string, okay, with this one, but close it. Okay, okay, Google Chrome doc.cr and okay. Okay, you see that if I go on it, I have the coordinates, okay? Naturally, in this moment, I'm not using them, but I have the data necessary, okay, to map the text on the image. So when I search for the text, I can retrieve the exact position on the image, okay? This is the reason that you can generate, for example, searchable PDFs, okay? So considering that this is XHTML, okay, and so it is an XML file, you can manipulate it, okay, and use this information, for example, in your website, okay? Is it clear? Questions?
I don't know how they know what's the difference between an HTML file and XML file, but
okay. So an HTML file, they are two different kinds of serialization of the HTML model. Okay, the HTML files are SGML files. So it means that, for example, BR can be open and never closed, okay, because it is the DTD that expresses it, okay. So you can have some elements, okay, that are expressed by tags that are opened and not closed, okay, and also the some attributes, okay, can be not associated to the values, okay. So for example, selected and not selected equals yes, okay, or equals true, okay. So it means that an HTML file, okay, is not a legal XML file. On the contrary, an XHTML file is an XML file, and so you can manage it with transformation style sheets. You can query it by xqueries and so on. Is it clear? Enrica?
it's for me it's clear, but I don't know if for the other. But I think they understood that you can work with Tesseract in order to make him learn how to manage the text.
Yeah.
I don't know, but they can speak by themselves. Huh?
Yeah, questions?
Tesseract, does it work only by command on the terminal, or there is a graphic interface? There isn't anyone?
No, unfortunately, it works on command line.
So if you wanted to learn better how to use Tesseract, if this kind of tool you think is interesting for your project, you have to learn how to use the command line in the computer, and I can send you now a link where you can find 4 lessons in order to learn how to manage these issues. So how to work with the computer using the basics command line commands.
Yeah, thank you, Enrica. And naturally, we are also at your disposition or in the next days, in the next months, if you need more information about that. Okay, I guess that it is very important to be able to use the command line. Why? Because in this way you can scale, okay, your projects. So from single small, very accurate projects to projects that work on huge amounts of data, okay, and these operations must be automated, okay? You must be able to create scripts that read lists of files and perform operations on each file with batch scripts, okay? Batch scripts, it means that the single operations that you should perform manually on a single file can be grouped inside the script and performed together. Okay. Okay. So yeah. I continue?
Yeah, go on.
Okay. So early printed editions and unwritten text recognition. Early printed editions and manuscripts are challenging. Complex and irregular layout, abbreviations, ligatures, irregular letters are present in both, okay? Even naturally, if the early printed editions, so the early printed editions are hybrid, okay, are an hybrid between manuscripts and late printed editions, okay. Some conventions and so on that were present in manuscripts are present also in the early printed editions. So in some cases, you can treat the early printed editions as printed editions, and in other cases, you can treat together with the manuscripts, and so to apply the same strategies for the recognition. In this case, you see something that I like a lot, I must say, I must confess that I like a lot, okay, that is the application of Kraken on early printed editions, okay. So Kraken, as I said, derived from Octopus, okay, and works very well on cursive scripts, okay. You see that in this case you have for example this fronunta, okay, word, okay, that has the ligature of rho and omicron, okay, that is recognized in very good way, okay. How to train Kraken? So Kraken can be installed on Macintosh and Linux, okay. It is quite easy to be installed, but I suggest if somebody of you are interested to work with me, okay. So I am at your disposition if you want to install on your specific computers, but we cannot do in a few minutes, okay. Because you must install Anaconda, so you have some prerequisite that we must follow, okay. There's a very good tutorial, okay, that you find here, and the example that are shown here derives from this website, okay, on Training Ancient Greek Early Editions. If you go here, okay, you can see the entire procedure, okay. Usually these procedures are very detailed, so if you follow it step by step, you are able to do it yourself, okay? Because it is necessary to train the script, okay, on at least 5 or 10 pages at least, okay, and then to create a training data that can be applied to the entire document, okay. Okay, so where is it? How to train Kraken? How to train Kraken? Yeah, exactly. Kraken has a command line, command. Okay, has a command that is called Ketos. Okay, that help you to make the association between the image, the line image, between the line image and the corresponding ground truth. So the corresponding accurate manual transcription. If you launch this script, that is this command, this Ketos, and you pass. So Ketos is an application. You launch the application Ketos and you provide the command transcribe, okay, on one or more images, okay, an XHTML file is created, okay, that is totally empty, okay, but with the correct coordinates to the image, okay. So if we open this file train HTML, okay, when we move on the image, the corresponding text box is highlighted and you can write your transcription, okay. You can do it on 5 or 10 pages according to the complexity of your script, okay, and then this information is used to train the system and to create a training data set for your specific document, okay. Okay. So now we will see the strategies to improve OCR and HTR. Why? Because when we have created when we have recognized the text and we have created the output files, okay, we can work on them automatically in order to improve the accuracy, in order to have a better text after the recognition, okay? First of all, we must understand what we mean when we speak about accuracy, okay? So the OCR is evaluated according to the accuracy that is a measure that is expressed by the following formula. The matches out of matches plus additions plus deletions, okay? And sorry, I haven't written here, sorry, there's a small error. I must correct it. Sorry. matches, matches plus mismatches plus, okay, now it's correct, okay, matches plus mismatches plus additions plus deletions. What it means, the matches are the correspondences between the ground truth, that is the accurate transcription made manually, okay, and the result of the OCR, okay. The mismatches are naturally the substitutions, so the wrong understanding of a character, for example, an M instead of an N, okay. The additions are characters that are added wrongly. So, for example, the apostrophe that you said previously, no? So an apostrophe is added, but this apostrophe shouldn't be there, okay? And the deletions are characters that should be there, but they haven't been recognized, okay? So the accuracy is based on the fact that we evaluate the true positive and the true negatives out of all the true positive, true negatives, false positives, and false negatives, okay? The matches are the agreement between the OCR result and the ground truth. So we will see in a few slides how to evaluate these matches, okay? OCR and handwritten text recognition can be improved by the post-processing, and a couple of strategies are worthy of attention. The alignment of multiple and independent OCR engines with efficient selecting criteria, the alignment to different editions of the same text with criteria to distinguish between OCR errors to be corrected and the genuine variants. What does it mean? It means that, okay, we can perform, for example, 3 times the recognition with 3 different OCR engines, and then align the outputs. When the 3 outputs are the same, it's okay. When the outputs are different, we must select the most probable one. The most simple and trivial policy is 2 against 1, okay? But the more sophisticated ones are the evaluation of the probability that one character is provided by an engine when the other engines provide wrong characters. Okay, so to evaluate character by character, which is the specific conditioned probability, character by character, okay, and naturally also the use of dictionaries, okay. So if 2 engines provide different erroneous tokens, okay, and one of them provide a word that is recognized by the spell checker, okay, the word will be chosen instead of the known words, okay. This is another possible strategy, okay, that naturally isn't always a good strategy because, for example, names of people, okay, could be not inside our dictionaries, okay, and so they could be substituted by another word, okay, with a similar spelling, okay. So we must evaluate which is the best strategy for the alignment of 3 different OCRs. The alignment to different editions of the same text is very effective when we are working, for example, in the philological domain, okay? In particular, in the domain of classics, okay? Because, as you know, we have many different editions of the classics, okay? And we could want to acquire many of them, okay? And some of them could be very correct and used like a quasi ground truth, okay. That means that the text of one edition, okay, is compared to the text of another edition, okay. But naturally, in this case, we must have criteria to recognize the OCR errors by the true variants, okay. Naturally, if you have in one edition the word casa and in the other magione, okay, this isn't an error, this is a real variant. But if you have in one edition casa and in another one, I don't know, something that can be at all, I don't know, kaya with a y, for example, okay, or k equals, for example, k equals a, okay, because the s is not correctly connected in its parts, okay, casa and k equals a will be corrected by casa, okay, and on the contrary, casa and magione are recognized as real variants, okay. The alignment is very nice, okay, because the alignment can be performed automatically, okay. There are very well-known alignment algorithms that are motivated by bioinformatics, okay, for the alignment of DNA, okay. In this case, you see, for example, that the ground truth is an example, and the OCR output is an exami, okay. The character alignment, okay, as you can see, aligns A to A, N to N, E to E, X to X, A to A, M to M, P to empty, okay, to nothing, okay, to a gap, L to a gap, and E to E. In this case, we have 2 character errors, okay, and 1 word error, okay. In some cases, you could have wrong alignments, okay, at the level of the words, okay. So now it is worthy, I guess, to see how these extremely important algorithms work. So if we open this link that I want to share to you. Just a moment. I want to share with you this link. No, why? Yeah, okay. Okay, so copy the link, go here and paste it. More actions. Where is the chat? I need the chat. Ah, okay. 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 So please go on this website, okay? So you can understand better how the alignment works, okay? As I said, the alignment is crucial for the OCR, okay? Because it is used both for the evaluation of the results, the evaluation of the performances, okay, and for the improvement of the OCR, okay? So if we go there, you see that you can write a sequence of characters. For example, giocare, ok, and mi piace giocherellare. Re. Ah no, mi piace un, so let me change, un gioco, for example. Okay, do you see that it has correctly aligned N to M, I to A, and so on, and then U to nothing, M to nothing, okay, and then G, okay, to G, I to I, O to O, C to C, O to A. This is considered a mismatch, but it is okay because it is a compact way to align them, okay, with something wrong that is a substitution, okay, and nothing to R and nothing to R. So you see that, for example, if I have mamma and ma, okay, you see that here we have two substitutions and two wrong insertions, okay? So it means that I have 4 errors, okay? How it works? It works, so this is the algorithm in action, okay, that show the cheaper, okay, path to go from A, so from the final A to the beginning, okay? So this is the minimal path to go from A to M. And when you move in this direction, you put, so when you move in diagonal, they are aligned. When you move in horizontal or in vertical, you must add the gaps. Okay? Questions?
I think now they are without the sugar in their blood and unable to do any feedback, but maybe after lunch they can organize better their thoughts.
Yeah, very good. Very good.
Okay, let's stop here. I stop the recording.
Thank you.
And